Thank you so much for joining this lesson. We are going to wind up with Mokasa joint examination. As I've been telling you, this is a joint paper which has been done by three great institutions. That is Moi Girls, Eldoret, Moi Kabarak, and the Sacho High School. So those are the schools that sat down and came up with this great paper. Those who have been in our meetings, they know very well that we've already discussed every question step by step in section 1. And now we shall be proceeding to the section 2 of this great paper. So stay tuned until the end of this meeting. Remember to subscribe. Remember to share so that you may invite a friend to our great discussion. As we continue learning together, please allow me talk something about our great programs here, which are causing a lot of impact to the candidates and also the continuing students in junior school and also in senior schools. The programs are next peer-aided, meaning that for the candidate classes, they are being guided on how to answer questions, on how to wait for this particular paper. So people are being given the right tips for KCSE and KGCSE by serious facilitators, and we shall be continuing from the Monday of 17th up to the Friday of 21st. So please use our information on this poster 0704 15 33 66 to enroll to our classes. Our till number is already pinned on the poster 497740. So you can use it to respond to your respective category here. Then we communicate and you get your assistance. Allow me to say that we are also having extra programs, guidance and counseling sessions. And in the first Friday of our program, that is the 14th of August, we shall be handling the topic managing peer pressure. And our speaker that day is set, and it's none other than Sir Alex Kiprutomayo, a teacher at Alliance High School, who is the founder and also the CEO, Abasanda Foundation. This is a great speaker, and you cannot afford to miss. You cannot afford to miss on Friday from 7:30 p.m. That is 14th August. The target group is senior and junior school students plus young adults. So you can join us so that you are guided on how to manage peer pressure. I shall be there to moderate the meeting, and you can be sure that this one shall be great. The outcomes shall be amazing. We are only charging 500 for the session, and the till number is the same, so you can use it and communicate with us through our phone number. Do not miss out, please. Then, on the last Friday of the August holiday, we are also having another powerful speaker, and that is none other than Dr. David Mwangangi. This is from Migwani Boys High, who is a licensed professional counselor. David Mwangangi is going to guide us on the topic, finishing strong. Here, you cannot miss out. Whether you are finishing your grade 7, your grade 8, your grade 9, your form 4, your form 3, your grade 10 work, regardless of what we are finishing this year, we are going to finish strong, and we shall be guided on how to finish powerfully and strong. This is going to happen on the Friday of 21st August 2026, time 7:30. So please be found in our meetings, and you shall not regret. Use the same till number, the same amount for the session, and all shall be great. So please do not be left out in these particular programs. They are made to simply build you, to make you stronger, to make you navigate the streets in a very wise way. So do not be left out. Do not be left out. We are here to ensure your success. Now back to the paper where we're going to discuss every question bit by bit. Very serious items here, and I hope through your cooperation, the discussion shall be fruitful. At the end of a trading session, three businessmen, Peter, John, and Thomas, shared a net profit of 620,000 Kenya shillings based on their ratio of their contributions. Peter got 3.5 times as much as John, while John got 1.5 times as much as Thomas. Calculate Roman 1, the ratio of Peter's share to Thomas. I thought it's Peter, John, and James, the most favorite disciples of Jesus Christ. Kumbe we have Thomas this time round, who was doubting Jesus Christ. So allow me now get into this question. It's very good you flow with me in the analysis of the same question. We're being told this, that when they started sharing, Peter received 3.5 times as much as John, while John got 1.5 times as much as Thomas. So we can let the share that went to Thomas be X. Can start with Thomas. So let Thomas share be X. So that now we interpret John, while John got 1.5. So John share shall be 1.5 times what Thomas received. You see that statement? Then can we go back now to Peter? The first statement. We realize that Peter is going to receive 3.5 times as much as John. 3.5 times what John received. This is exactly when we multiply 3.5 and 1.5, we're getting 5.25. You see that? 5.25 x. Now, these are the proportions in which 660,000 Kenya shillings was shared. So we're saying when we take the first proportion, we add the second, and we add the third. This will amount to 620,000. In the place of X, you can use any other part of the algebra, and you shall be good to go. 7.75. I hope my addition is accurate. Equals to 620,000. Now, to remain with X, you can divide both sides by 7.75, and this will leave us with exactly 80. 80 is the value of X. So if 80 is the value of X, it means in the sharing of these particular profits, Thomas received X, which is now 80. So we can have Thomas there. Or we can have John at this point. We can have Peter at this point. Thomas is receiving 80,000. What about John? Because I want to distribute the amounts so that they may give us ratios. So 80 times 1.5, we're going to get exactly 120. 20,000. Then for Peter, it shall be 5.25 by 80,000. And this is going to be 420,000. So can we simplify the ratios now? Can we simplify the ratios? I think we can. So if we simplify the ratio of Thomas to James to Peter, you know that ratios are supposed to be in their simplest forms. When you divide by 10,000 across, we shall remain with 8, we shall remain with 12, we shall remain with 42, which can further be simplified. Yeah, can we do by 2? Or by 2 we shall get 4. By 2 we shall get 6. And by 2 we shall get 21. This is now the simplest ratios. These are the simplest ratios of Thomas, John, and Peter. Okay, after getting their simplest ratios, now we check the question. We find the ratio of Peter to Thomas, and it's supposed to be in such a ratio. Peter to Thomas, Peter to Thomas. So we start with Peter to Thomas, whereby we start with the proportions of Peter, 21, and Thomas proportion T, 4. So now 21 is to 4 becomes our final answer in Roman 1. Are we together in that part? Thank you. We can now check Roman 2 of the same question. In Roman 2, we're being told that we determine or we calculate the amount of money that Peter got over John. When you talk about over John, it's like we want to know how much more did Peter earn than John. Peter than John. So it's going to be Peter's amount minus John's amount. Is this not 300,000 Kenya shillings? You know, we already distributed the amounts into the respective businessmen. So when you take 420,000 and you subtract 120,000, definitely 300,000 Kenya shillings. 300,000 Kenya shillings. That is the more Peter earned, or the more Peter got over John. Over John, yeah. I hope I have related the right people. Exactly. That is now Roman 2. A very simple question, easy to understand. Now, can we check part B of this particular good question? Look at what part B is saying. Assuming that 4 out of 31 of the profit was retained for daily running of the business in the next session, and the remaining amount was shared as per the ratio of their contributions. Calculate the difference in the amount of money received by Peter and Thomas to the nearest shilling. To the nearest shilling. Now, here we're doing a different assumption now. You know, in the first case, after they realized 620, we're assuming that they shared the amounts and got these particular portions. But now we are told to assume that 4 out of 31 was retained. So how much is being shared now? So amount that they are going to share. Amount shared. You see, 4 out of 31 proportions have been shared. So how many proportions have been, okay, 4 out of 31 has been retained in the business. So how many proportions out of 31? We subtract the 4. So it's 27 proportions out of 31 of the profit. This is now what is going to be shared to the different persons. So it shall be 27 out of 31 multiplied by 620,000. And this is going to be 5
540, sorry, thousand Kenya shillings. Now, this is what they are going to share because 4 out of 31 has been plowed back into the business for daily running of the business. So we are assuming now they didn't share the full amount, and we know the ratios in which they are going to share. From there now, the question can be given different approaches. We need to find the difference in the amount of money received by Peter and Thomas. Peter and Thomas. Can we check their proportions? Peter and Thomas. Their ratios were already worked out in Roman 1. 21 is to 4. 21 is to 4. So how many proportions are here first into which the money is being shared? 4 is to 6 is to 21. This is already 10, 31 proportions. Therefore, the 31 proportions, total proportions, 31, is the total profit being shared. Then you ask yourself, in this particular case now, how much is Peter going to receive 21 proportions? So how about the 21 proportions being received by Peter? So 540,000 by 21 out of 31. So times 21 over 31. We're going to get 365,806.50. That is now the amount the first person here, that is Peter, is going to receive. Actually, we can indicate that this is Peter. Then we ask ourselves, and what about this other individual who is Thomas now? What about Thomas? Thomas now shall be receiving. How many proportions for Thomas? For Thomas, it is only Peter is 21. Thomas is 4 proportions. So 4 proportions out of 31 multiplied by the profit being shared. So Thomas is going to receive 4 over 31 multiplied by 540. This is exactly 69,000. 677.40. Then now we wanted the difference now between the amounts the two are going to receive. So the difference shall be given by 365,806.50 minus 69,677.4. So in Kenya shillings, the difference shall be 296, 129.08. Remember, we're supposed to give to the nearest shilling. So this is going to be Kenya shillings, 296,129 to the nearest Kenya shilling. That is the amount they shall receive. Yeah, that is the amount they are going to receive. Very good. If that is the amount, or that is the difference in the amounts the two individuals are going to receive. Continuing to analyze the same question, we can look at part C. Now, in part C, the question says that in the second trading session, a net profit of 744,000 Kenya shillings was made. The three businessmen decided to plow back their shares into the running of the business. Thomas decided to inject more money into the business up to level equivalent John's contribution. Calculate the extra amount of money added by Thomas. Now, when the profit shared is 744,000 Kenya shillings, and we know the ratios of contributions. We know the ratios as Thomas, John, Peter. Thomas, John, Peter as 4, 6, 21. Okay. 4, 6, 21. Now we are asking ourselves, we calculate the extra amount added by Thomas so that they may be equivalent to who? They may be equivalent to John. So they are going to plow back the profits. Then what John will have given is going to be above what Thomas will have given. So Thomas will have to top up now from his pockets, because from the profits, he's plowing back something smaller. So he's topping up from his own coffers now to ensure that in the business, he's having equal shares to John. So can we get first what John is going to get according to the proportions? John shall be receiving 6 out of the 31 of 744,000. So the amount plowed back according to John's account shall be 6 over 31 multiplied by 744, 1, 2, 3 zeros. This is going to be 144,000. This is now the amount after plowing back, which will go to John's account. What about Thomas? Thomas is plowing back 4 proportions out of 31 of 744,000, meaning that Thomas is plowing back 96,000. 96,000. Therefore, he wants in the business to be having equal shares to John. Thomas wants to be equal to John. So the extra amount that he's going to look for so that they may be equivalent shall be 144,000, and we subtract what he's already having so that we know what he's going to top up. This is now the extra amount that shall come from his own pockets now, which is 48,000 Kenya shillings. Alternatively, we would have said that the extra amount is supposed to come from the difference in their proportions. So between Thomas and John's proportions, there is only 2 proportions, 6 and 4. The 2 proportions out of 31, 2 proportions will correspond to the extra amount. So somebody is paying extra because there's a difference in the proportions. 2 over 31 multiplied by 744,000. We get exactly 48,000. Instead of using a very long method, you would have still gotten to this directly. The same too, the difference that we were obtaining between Thomas and Peter, we would still have gotten the difference in their proportions. That's why I said there are different approaches you can use there. So you can just get the difference in the proportions and you compute the answer directly, the way I've shown you about the extra amount that Thomas is supposed to add so that they are equal to John. A good question about ratios and proportions. A very, very good question. So thank you for following up. Please type if you're learning something on the comments section. Type yes, I'm learning. Are you getting something really? Are you understanding how to evaluate these questions? Are we together as we flow to number 18, which is on a linear motion and specifically relative speed? So we check it now together. We're being told in number 18 that the distance between two towns, P and Q, is 760 kilometers. A minibus left town P at 8:15 a.m. and traveled towards Q at an average speed of 90 kilometers per hour. A matatu left Q at 10:35 a.m. on the same day and traveled towards P at an average speed of 110 kilometers per hour. Part A, how far from P did they meet? How far? So let's try to demonstrate this particular journey on linear motion. We are having two terms, P and Q. So P is here and Q is on the other end. We are already given the distance between the two as 760. Then a minibus is starting its journey at P, 8:15 a.m. Then it travels towards Q at an average speed of 90. And later in the day, same day, a matatu is leaving Q towards P at an average speed of 110. Now, our question is, by the time this matatu is leaving Q, you see, the minibus has already covered the distance from P to some point. It's somewhere in the middle of this particular straight road. Therefore, we need to know the distance covered by the minibus before the matatu began its journey. So, distance covered by minibus shall be given by, generally we say that a speed is equal to distance out of time. At this level, you know what you call changing the subject of a formula. So to remain with distance, we have to multiply by t both sides. So distance is given by speed times time. So this particular matatu or this particular minibus is using a speed of 90 and it has already traveled for some time. It has traveled for some time all the way to 10:35 from 8:15. On the minute side, we're getting 20. On the hour side, we're getting 2. So 2 hours and 20 minutes. 2 hours and 20 minutes. You see, this is 2 and 20 over 60. So that it becomes 2 1/3 an hour. So times 2 1/3 of an hour. So that you may know the distance the minibus has already covered from P before the matatu began its journey. So this is 90 times 7 over 3. 90 times 7 over 3. 90 times 7 over 3. I'm getting 210 kilometers. So the minibus has already covered. This is now by 10:35 a.m. The minibus has already covered to 10 kilometers, meaning that the remaining distance now between the two shall be, the total distance was 760, and now 210 has already been covered, meaning that the remaining distance between the two towns is now 550 kilometers. So by 10:35, these two vehicles are having a distance of 550 between them. 550 between them, and it's 10:35. How far from P did they meet? Now, how is this particular distance going to be covered? Actually, it becomes our relative distance. The distance between the two vehicles at any given point, we call it the relative distance. So there's a relative distance of 550 kilometers per hour. Then this particular relative distance shall be covered at a relative speed. Now that they are facing one another, now that they are approaching one another, to narrow the distance between them, relative speed shall be the sum. When two bodies are approaching one another, their relative speed is usually the sum of the individual speeds, because they are assisting one another to narrow this distance. The distance of 540 is being covered jointly by the two speeds. So 90 and 110, is it giving us 200? So it's a speed of 200 kilometers now per hour, which is being used, to cover the distance between them, meaning that we can get the relative time, the time taken now to cover the distance. Time is given by distance out of speed. So what are we going to get at this point? We divide by 200. I'm getting 2.75 hours. 2.75 hours. Then now we get back to the question. How far from P did they meet? At this point now, we can consider the vehicle which is moving from P. Now, from 10:35, they shall take 2 hours and 2.75 hours, all right? So if this is the time taken, and the vehicle from P is using a speed of 90, then there is some distance which is going to be covered. So we can call it distance 2, which is going to be covered at a speed of 90 for 2.75 hours. So it shall be exactly 247.5 kilometers. 247.5 kilometers. Then we can ask ourselves again some few other questions. So from P, the total distance from P to the meeting point shall be the first distance, which was 210. And now the same minibus is covering further 247.5 for them to meet. So eventually they are meeting after what distance? We can now add the 2, 457.5 kilometers from P. That is now the distance from P to where they are going to meet. Alternatively, we can consider the other vehicle, which is moving from Q, where we shall say this distance can be given by the distance from Q to the meeting point at a speed of 110, taking 2.75 hours. So the distance to the meeting point the matatu shall cover will be, moving at 110 for 2.75, we're going to get 302.5 kilometers. But this particular matatu is moving from Q. The examiner wants the distance from P. So from P, it shall be the total, which was 560, no, 760, I think. Yeah, the total was exactly 760. So now we subtract what we are covering from Q so that we know how far we are from P. So 760 minus this value, we get exactly 457.5 kilometers properly computed. You see? So we are through now with the distance from point P to where they are meeting. Roman 2 of part A. In Roman 2, the examiner is telling us to find the time they met, the time they are meeting. So they are taking what long? They are taking how long? They are taking 2 hours. You see, 0.75, that is a 3/4 of an hour, which is 45 minutes. And they started now moving together at 10 what? It is at 10:35 when the two of them now are in motion. The matatu has started moving. The minibus is also continuing with its motion, and they are taking further. So from 10:35, We are taking further 2 hours, 45 minutes. When we add the minutes side, 35 and 45, we are getting 80. So 80 minutes means we can remain with 20 minutes and we carry 1 hour. 10 plus 2 and plus 1. This becomes 13. So they are meeting at 13:20 hours. Since the time has not been specified, the system we are supposed to give the time in, a student that writes 1:20 p.m. shall also be considered to have done the right thing. So it will be correct that way. So that's how simple the Roman 2 is. Can we check part B now? In part B of the same question, we're being told that a motorist starts from his home at 10:30 a.m. on the same day and traveled at an average speed of 100 kilometers per hour. He arrived at Q at the same time as the minibus. Calculate the distance from Q to his home. Remember, the minibus is going to Q from P. Then the time the minibus is going to arrive, it is also the same time the particular motorist is also going to arrive. So the question here is, what is this arriving time? What is this arrival time? So can we check arrival time of both? Because they are going to arrive at the same time. So arrival time or time taken, time taken by the minibus shall be for a distance of this out of a speed of 90. 760 over speed of 90. We are getting 8 hours. 400 over 9. Yeah. Hours. That it will be exact. If the minibus is taking this time and it started moving at exactly 8:15. From 8:15 up to 10:30 when the motorist is starting, the motorist has been at rest. Therefore, we can also find the time taken by the motorist, because up to 10:30 from 8:15 up to 10:30 from 8:15 up to 10:30 from 8:15, the motorist has not been moving, but the particular minibus has been in motion. Therefore, what is this difference? 15. This is 10:30. This is 8:15. Yeah, I want to subtract the exact things. So 15, and this is 2. So 2 hours and a quarter. 2 hours, 15 minutes means 2 and a quarter hours. So for 2 and a quarter hours, the motorist was not moving, meaning that we can find time taken by the motorist. The motorist is going to take, instead of 8 and 4 over 9, we subtract the 2 and a quarter hours when it was not moving. So we subtract 2 and a quarter. When you perform that subtraction, you shall be arriving at exactly, let me give the exact time, 6, 7 out of 36. 6 and 7 over 36 hours. So this is the time now purely taken by the motorist, because we've said time taken by minibus is the total distance to be covered out of the speed of the minibus, which is 90. So this was the total time taken by the minibus. Now, the motorist is starting at 10:30, but arriving at the same time as the minibus. That means it will have traveled for, we check the time it was at rest. So for them to arrive together, it means it's only going to be in motion. We subtract the 2 hours and a quarter when the motorist was at rest, yet they arrived together. So it means the motorist has covered now the extra 6 hours, 7/36, meaning that we can now find the distance. It is going to take this time, and it's moving at a speed of 100, meaning that the distance covered shall be given by speed times time. A speed of 100 multiplied by 6 and 7/36. So this now shall be exactly 619.44, or we can make it n4/9 kilometers. 619 and 4/9 kilometers from the home to where they are meeting. I hope you got that point now. I hope you got that idea and how that question has been executed. We had to get the extra time, which becomes now the time the motorist was in motion. So that is now the distance from the motorist home to point Q. A very technical question, which requires somebody to think, to reason so deeply. It might be given a different approach anyway. In the interest of time, allow me to settle at that. Then we proceed together to number 19. I don't know whether you are remembering about our programs here. I don't know whether you are joining us late, but allow me mention to our followers that our one-on-one classes, which are very interactive and via Google Meet, are already continuing. Here, people are really benefiting. So you better join us and consult our team of facilitators, people that have been marking the national exams for the longest, people with the best experiences. They can guide you, they can lead you into your success. So do not be left out. Then on top of this, ladies and gentlemen, I hope you've seen our number. That is what you're supposed to use to reach out so that you may book your chance for our discussion classes. Then it's good for you to know that we have guidance and counseling sessions, which are also going to happen via Google Meet. In our first session on the 14th of August, we're going to host the one and only Sir Alex Kipruto of Alliance High School, who is the CEO and also the founder, Ambassador Foundation. Please join us and experience a very powerful meeting discussing managing peer pressure. That's our first topic, and is going to take charge. You can be sure it shall be powerful. So please join us. We're going to charge only 500 for the whole session from 7:30 p.m. on Friday, 14th August. The target group is going to be senior school students, junior school students, and young adults, those who want to maneuver the streets, the schools very wisely. You are invited to join this powerful meeting. You are invited to join this particular meeting. Then, ladies and gentlemen, we also have another experienced and very powerful speaker for our sessions. That is none other than Dr. David Mwangangi. David Mwangangi is from Miguani Boys. This is in Kitui County. He is a licensed professional counselor, and is going to lead us on the topic, finishing strong. I shall be here to moderate the meeting, and you can be promised of a fruitful day. It shall be great on the 21st of August, Friday 2026. Please join us again, the same target groups, and the meetings shall be via Google Meet. Google Meet. So please do not be left out. You can reach out so that you book yourself a slot. We are here to ensure that our followers are all around. So do not be left out, enjoy our guidance and counseling sessions. Now proceeding to number 19. All right. Yeah, number 19. We told that the businessmen bought is it the businessman or a businessman? This should be a businessman, right? Or maybe we continue reading the question. Maybe it will make sense with time. Anyway, a businessman bought 3 cows and 7 goats for a total of 95,000 Kenya shillings. If he had bought 2 cows and 8 goats, he would have spent 15,000 less. Form 2 linear equations to represent the above information. Now, we're supposed first to interpret this particular information into linear equations. We can let the cost of a cow to be C and that of a goat to be G, just for relevance and for easier correlation. So we can say a cow is costing C and a goat is costing G. So from the first statement, 3 and the cost is C plus 7 goats and the cost is a G, we are totaling to 95,000. 95,000. That is equation 1. Further, we're being told that if he had bought 2 cows and 8 goats, you would have spent 15,000 less. So we take 95,000 and we subtract 15 and we get 80,000. So we're going to have 80,000 spent. We have the 2 linear equations, and that is what the examiner wanted. Now in part B, we told to use matrix method to determine the cost of a cow and that of a goat. The cost of a cow and that of a goat. Allow me start managing the space up there. When you have linear equations, you usually proceed to extract what we call matrix equation. A matrix equation is given by, first, coefficients matrix. When you pick 3, 7, 2, 8, 3, 7, 2, 8, you have now obtained what we are calling the coefficients matrix. Then the 2 variables, whatever is being solved, is a C and G. This is called the variables matrix. Then on the other side, on the right-hand side now, we have constants matrix. Constants matrix. Constants matrix. Constants matrix. We're going to learn a lot on matrices before we finish the question. Constants matrix. So this is now a matrix equation made of coefficients matrix, variables matrix, constants matrix. Are we together at that point? Thank you. Now at that point, we are proceeding. We are at part B already. I'm working out part B already. It's good for you to know that. We're already working out part B, so we're just doing a continuation. After extracting the matrix equation, you proceed to find the inverse of the coefficients matrix. And to find the inverse, you usually start with the determinant. The determinant. What shall be the date? The date shall be product of the elements in the leading diagonal, the main diagonal, the principal diagonal. The diagonal having 3 and 8. Then we subtract the other diagonal, products of the elements in the other diagonal, which are 2 by 7. So this particular determinant is going to be 3 by 8, which is 24, minus 14, which is 10. So the determinant is 10. Now, how do we get the inverse of the coefficients matrix? Now, inverse is going to be given by, we're going to exchange the positions of the elements in the main diagonal. Elements in the main diagonal. So we are having 3 and 8. They change positions. 8 picks this position, 3 picks this position. Then elements in the other diagonal, they change their sign. If it is a negative, it becomes positive. If it's a positive, it becomes negative. So this now becomes -7. This becomes -2. Now we are multiplying. We are in the process of finding inverse. The first thing, you exchange position for elements in the main diagonal, and for elements in the other diagonal, we change their sign. Then we divide each element by 10. We divide each element by the determinant. When you divide by the determinant, it's like multiplying by 1/10 to divide everything. This now becomes 0.8, -0.7, -0.2, and 0.3. So I've divided everything by the determinant. So this is our inverse now. Now, after finding the inverse of the coefficients matrix, the next step, and I hope you are writing down these steps so that when you take a different question, you can maneuver and find yourself at the answer. First thing, we've said from the linear equations, extract the matrix equation. We did that. Then you find the inverse of the coefficients matrix. To find the inverse, we begin with the determinant. The determinant of a matrix is a product of the element in the main diagonal minus product of the elements in the other diagonal. And we subtracted and got 10 because that's 24 minus 14. We got a 10. Now, to find the inverse now, we divide by the determinant everything, but now we change positions for the elements in the main diagonal and elements in the other diagonal. We just change the sign like that. So I've now divided each by 10 to get that. So we have our inverse. So the other step now is to pre-multiply both sides of the matrix equation by the inverse of the coefficients matrix. So we're going to pre-multiply 0.8, -0.7, -0.2, 0.3, multiplied by, the equation was 3, 7, 2, 8, CG. This is now equal to, we also multiply this other side. Multiply this other side. So the inverse should pre-multiply like that. We are having 95,000 and 80,000. So we have pre-multiplied both sides of the matrix equation by the inverse of the coefficients matrix. Now, after that pre-multiplication, are you able to remember this? That when you take a matrix and you multiply by its own inverse, it's like we are multiplying something by its own reciprocal. We usually get 1. So we get the identity matrix. What is the identity matrix? A matrix with 1 in the main diagonals and zeros elsewhere. Therefore, we don't need now to multiply this. We don't need to multiply this. We don't need to perform the multiplication. A matrix and its own inverse will automatically give us the identity matrix. 1, 0, 0, 1. This now multiplies CG. And this is equal to, now multiplication can be performed on the other side, whereby to multiply a matrix requires us to multiply a row times column. So 0.8 by 95,000, -0.7 by 80,000. We see what to get. So 0.8 into 95,000, -0.7 into 80,000. What I'm getting is exactly 20,000. Then the next row and the same column. So I'm starting with negative 0.2 by 95,000, 0.3 by 80,000. So negative 0.2 into 95,000, positive 0.3 into 80,000. This is giving us exactly 5,000. 5,000 like that. Again, you're supposed to remember, according to matrices, any matrix times the identity matrix remains unchanged. It's like we are now multiplying a matrix by 1. The value of the identity matrix is 1. So again, on the left-hand side, you don't need to perform this multiplication. A matrix times the identity matrix remains unchanged. So we're having C, G, becoming 20,000, 5,000. You're supposed to enclose matrices like that. And now we can conclude that a cow, C, is costing 20,000 and a goat, G, is costing 5,000 in this particular market center where the businessman went to buy the cows and the goats. A very good question on matrices. We can continue working out this question. Look at part C of this question. In part C now, we are done with linear equations and matrices. Now we are on general interpretations, which can actually be a part of commercial arithmetic, general knowledge now, whereby we are told that the businessman later sold the animals he had bought, making a profit of 40% per cow and 30% per goat. Calculate the total amount of profit he received from a cow. From a cow, 40%. So 40%, and a cow was bought at 20. So the profit shall be 40% times 20,000. This is a profit of 8,000. Then 30% for a goat. 30%, and a goat was bought at 5,000. So 30% by 30,000 by 5,000, sorry. This is now going to be a profit of 1,500 per goat. So total profit shall be 8,000 times how many cows were there, because each cow, the cows were 3 and the goats were 7, times the 3 plus 1,500 for the 7 goats. So now we can compute this. 8,000 by 3 giving us 24,000 from all the cows. Then 1,500 by 7 goats, 10,500 from all the goats. So now the total profit can be compiled now. When we add 24,000 here, we're getting 34,500. This is a very good profit. This question is also brought about to lead you into some business ideas. We call it the fattening business, whereby you can buy some cattle, some sheep, some goat, and for 2 weeks or some time, you let them fatten a little bit. You feed them very well, and you take them back to the market. You take them back to the market. You realize that you will attract more sales than the amount you used to buy them. It also depends with the season. So you should be very good in studying the seasons. The experienced businessmen in that can explain, but it's a good business. According to what we can see, a certain businessman that we don't know is making 34,500. Maybe this was within a week. We don't know. Then part 2 now. Part 2. Determine the percentage profit the businessman made from the sale of the animals. Percentage profit. So we are having all the profit, then we have the total amount that he used. So profit out of the buying price. Profit of a buying price, we expressed as a percentage. Profit over the buying price expressed as a percentage. Percentage profit is now given as profit over buying price of everything. You know, this profit, the general profit from everything over how he acquired everything. Then we make it a percentage. So this we multiply by 100 over 95,000. It's becoming 36.32. 36.32%. I've made it a 4SF, 32%. That's a very good question. Very, very excellent question. Have you followed through? Have you been with me throughout the working? Thank you. Then if you follow up with a question like this, fully attentive, then you cannot miss when it comes in the final examination. So thank you for following up. Please remember to subscribe. Remember to share our platform with your friends. We are growing this particular platform and we rely on your support. So subscribe and share so that you may invite others. In number 20, we're being told, number 20, we're being told that a region R is bounded by the curve y equals to x power 3, x-axis, and the lines x equals to 0 and x equals to 6. Part A. Estimate the area of region R using the mid-ordinate rule with 6 strips. Mid-ordinate rule with the 6 strips. All right. So I want to show you how to interpret this language of strips first. You know, you're supposed to know that the area can first, we first, before sketching this area, because I want to install this particular concept in your head by force, you must understand the mid-ordinate rule. So allow me first see the values of x, how they are varying within the ordinates that we have within the strips here. So we have x and y, 1, 2, 3, 4, 5, 6, 7. So we have x and y, from 0, 1, 2, 3, 4, 5, 6. Again, we are having the values of y, which are given by x power 3. So 0 power 3 remains a 0. 1 power 3, so that you may get the corresponding value. 1 power 3, it becomes a 0. 2 power 3 becomes 8. 3 power 3 becomes 27. 4 power 3, is it 64? Yeah, something like that, 64. Then 5 power 3, it becomes 125. All right. We are also using 6 power 3, 6 cubed. It's going to be 216. 216. So now, just a sketch of this particular information. Just a sketch of this particular information. That's a sketch of these particular values. I want to show you the area and how it's behaving. 1, 2, 3, 4. This is from 0. 5, 6. Okay, up to that point. So at 0, we are already there. Then at 1, we are having 1. At 2, a bigger value. At 3, a very big value. At 4, a very big value of y. At 5, a very big, very, very big. So they are very big values. That's why I've not written anything on the vertical axis. Then at 5, then at 6 finally. So this is how the curve is behaving. The curve is like that. That's how the curve is behaving. Now, you're supposed to know that we can join this particular curve, this particular coordinates like that, like this, these. So the area that we are talking about, bounded by the curve, the x-axis, and points 0 to 6 is here now, partitioned. So the area has been partitioned into what we call strips. These ones, the spaces are strips. These spaces are called strips. They are called strips, like that. Then we talk about the boundaries. The boundaries giving us these strips now. The boundaries used to partition. The boundaries used in the partitioning of the strips are called ordinates. They are called ordinates. You see? So now, when we talk about a strip, we mean the spaces which have been partitioned. And how many are they? Are they 6 strips? 1, 2, 3, 4, 5, 6 of them. Now, it's good for you to know that the language of 6 strips may also mean 6 ordinates, 6 mid-ordinates, 6 mid-ordinates, 6 mid-ordinates like that, because every strip is having a midpoint. So now, what you need to understand about the mid-ordinate rule now, we don't focus on the ordinates that are partitioning the area. We don't focus on the ordinates that are partitioning the area. Now we focus on the mid-ordinates. For every strip, we check the mid-ordinate, the value of y at the middle of every, the value of y at the middle of every strip. So now we have to come up with a table here, which now we shall use to substitute in the formula, which is now going to be used to substitute in the formula. So now we need the middle values. The middle values. 1, 2, 3, 4, 5, 6. All right. So we're having X, we are having Y. We can use a different color to fill that. So with the first strip, the middle ordinate, we'll have X as 0.5. With the next strip, 1 to 2, the mid value of X shall be 1.5. The next one, 2.5. The next value of X, 3.5. The next one, 4.5. Then 5.5. So those are the values of X at the mid ordinates. So the middle values of X, so that you may get corresponding mid ordinates of Y now. So what are the respective values of Y? we take 0.5 and we cube. For us to get the value of y, the function remains. So 0.5 power 3. This is going to be 0.125. I hope we are dispersed here. 0.125. Okay. Then 1.5, we also raise to power 3. 3.375. 2.5 power 3. This is a 15.625. 15.625. 3.5 power 3. We're getting 42.875, or about 4.5 power 3. 91.125. Then 5.5 power 3. We get 166. 166.375. All right, so we have the values of y at the middle of every strip. That is now the meaning of mid-ordinates. Mid-ordinate. If it was the trapezium rule, we would have used the values of y here. But now that it is the mid-ordinate, then we need to work with the middle values. So now we talk about area approximation. According to the mid-ordinate formula, we need height, which is the thickness of the strips. This is the thickness of the strips. Then the values of y, the first one, the second one, all the way to the last value of y. We just add the values of y. Therefore, the area will be estimated as the width of the strips is only 1 unit. So we're going to add 0.125 plus 3.375 plus 15.625 plus 42.875 plus 91.125 plus 166.375. You can perform this addition times 1, it remains. So 0.125 plus, it's good we add together, 375 plus 15.625 plus 42.875. We are adding 91.125 plus 166.375. This is giving us exactly 319. 319.5 times 1. This will become square units. So our area approximated using the mid-ordinate rule shall be 319.5. At that point, now you can allow me check what part B is talking about. Part B is telling us to determine the exact area of the region R, this region now that we've described, by integration. So you can see the area is on one side, so we just integrate once. The purpose of sketching, you're not supposed to work out area by integration before you sketch to see the behavior of the curve. So all the area is on the upper side of the x-axis. Therefore, we can integrate once the function from 0 to 6. So we integrate now from 0 to 6. Is this a 0? The function x power 3 with respect to x. So integrating this means we now going to have the power of x increasing. So the power of x increases to 4. So x power 4. Then the new power now divides everything.
like that. Because it's a definite integral,
we don't need even to substitute. We don't need to substitute, we don't need to add the constant of integration. So 0 to 6. So now substituting here shall be 6 power 4 out of 4 minus 0 power 4 out of 4. This becomes 0, of course, this part. It becomes a 0, yeah. That one is a 0, eh? Then 6 power 4. Then I divide by 4. I'm getting exactly 324. 324 square units. So by integration, the exact area is 324. If this is the exact area, look at the last question in this part. Calculate the percentage error in the area of region R when mid-ordinate rule is used. So can we find the error first? The error is usually the difference between a correct value and an estimated value. So the area was first estimated to be 319.5 using the mid-ordinate rule, but now from exact area by integration, you can see it's slightly different, meaning that we can find the error in the area. So subtract 319.5 and get 4.5 units. 4.5 square units. So percentage error is usually given by error out of actual expressed as a percentage. Error over actual expressed as a percentage. So performing this, we're going to get exactly a percentage error of 1 and 7 out of 18%. Remember, this can still be given as 1.3888, which can be 3.89%. So this is now the percentage error in the computation of the area using the mid-ordinate rule. So that is how number 20 was supposed to be approached. A very, very good question. If you're getting something, type yes, I'm learning. Type yes, I'm learning. And where are you learning from? What is your school? What is your name? Who is your math teacher? Are you valuing what the platform is doing? Are you recognizing our work? Do you think that you are benefiting from Shifting Grades Online School? As we proceed to number 1 on statistics, it's good I mentioned that statistics is a very frequently tested area by NEC. Statistics. Actually, any topic that has 1 and 2, we have statistics 1 and 2. Such a topic does not miss. Trigonometry, 1, 2, 3. We've said statistics. We talk about commercial arithmetic 1 and 2, quadratic expressions 1 and 2. Quadratic expressions may not be evaluated directly as like solve the following quadratic equation. No, it might be in application. Like when differentiating, when integrating, we come across functions that are quadratic in nature. So quadratic concepts are very highly applied when it comes to mathematics setting. So please familiarize, vectors, vector 1 and 2. Any topic that appears severally must always appear or be applied in a national examination. So we check statistics with that understanding now. You'll be very careful when working out a question like statistics because it will be there, it has been there, and it shall be there. Okay, so the results for mathematical test of 100 students. That's a very key statement. 100 students is as shown below. So we have the classes. Marks have been distributed into classes from 30 all the way to 70. These are very good class with a very small range. We don't have people with 0 to 10, and we don't have people with 80s. A very standard class. Then we can see the number of students, which we call the frequency. Number of students scoring a particular mark, we call it frequency F. All right. Now we're taught to determine the value of M. So along the frequencies, one of the values is unknown. It's M. Now, one thing that we've already been informed is that they are 100. So when you add up everything, you should get 100. 4 plus 6 plus 10. 4 plus 6 plus 10. 4. Check 4 plus 6 plus 10. 14 M24. 14 M24. 14 6. This is supposed to give us a total of 100, meaning that we can add every value here, every value. 4 plus 6, 10, 20, 34. 34 plus 24, we get 58. 58 plus 20, 58 plus 20, we get 78. Plus M equals to 100. So the value of M equals to, now 78 should be subtracted on the other side, giving us exactly 22, like that, giving us 22. So instead of M, now we are talking about 22. Can we confirm our addition? Can we confirm our addition by simply establishing, can establish our CF. We can establish our CF column here. Establish our cumulative frequencies here, just to be very certain before we work out values, to be very sure that we are not wrong. We can establish our CF. Allow me also make up these lines so that the work, every class is properly partitioned, and to avoid error as we continue. To avoid mixing up of values from one class to another, it's good we continue with the partitioning of these particular classes, like that. We are taking long, but it's worth it. You better have your work very decent and confuse things as you continue. Remember to subscribe. Now I've discovered there are people who follow us. They have never decided to be subscribers of Shifting Grades Online School. You will not lose anything. There are people that think when they subscribe, some 10 bob will be cut from their account to our account. No, just subscribe to popularize our platform. There is nothing, you stand to lose nothing when you subscribe. Is that okay? Thank you. Now we can establish the CF. We can establish the CF. Because I've used a lot of blue, let me change to red at that point. The first frequency is 4. Plus 6, we get 10. Now plus the next 10, we get 20. Plus 14, we get 34. Plus 22, we get 15. 6, then 56. Plus 24, we get 80. 80 plus 14, we get 94. Plus 6, we get 100. So we have worked out very well because the total is now 100. A good one. A good one. You're supposed to know some techniques. You don't have to proceed so much when you already worked out the value of M wrongly. You start realizing when you are working out part B, Roman 2, working out the median. You don't have to delay your accuracy until that point. You can confirm your work as early as possible. Now we state the model class. Model class is the class with the highest frequency. Class with the highest frequency. So look at the frequencies now. Along the frequencies, the highest frequency is at this point, 24. So the class that bears such a frequency. The frequency itself is called the model frequency, but now the class is the model class, 55 to 59. 55 to 59. Very good question. 55 to 59. We told further in part B to calculate Roman 1, the mean mark, and Roman 2, the median. Now that we have computed the CF, allow me deal with the median first. Then we get to the mean. So median, is given by lower class boundary of the median class. There are people that think the median class is the middle class. No, out of the total frequency over 2, because it's median, minus cumulative frequency just before, cumulative frequency before the median class, out of frequency of the median class multiplied by the class interval, rather the class length. Now, what we need to work out first now is the median class, because you can't start substituting values here and you've not established the median class. What is the total frequency? Total frequency is 100. Is that okay? So what is n over 2? 100 over 2, we get 50. So we want the mark. Median mark is the mark obtained by the 50th student. The mark obtained by the 50th student. So median class is the class containing total frequency over 2 according to the CF column. According to the CF column, where do we have 50? So in our case, the mark of the 50th student. Where is the 50th student mark lying? The 50th student. So we check the CF. This is only 4, so not at the 50 mark already. This is 10, not at the 50th. This is 20, so we are yet to be at the 50th student. So far, this is 34, so the 50th is yet. But here now we are accommodating up to 56. This class absorbs up to 56, meaning that the 50th is within this class. The 50th is within this class. So our median class is 50 to 54. Our median class is 50 to 54. Once you establish the median class, you can now proceed to substitute. After establishing the median class, you can proceed to substitute with a lot of comfort and ease. With a lot of comfort and ease. So, so we need to know that now substituting requires median. We know we need median. So we talk about lower class boundary, not limit, boundary of the median class. If the limit is 50, what would be the lower boundary? So we get back to that. For us to get the lower boundary, we need the limit, the lower limit, plus the previous upper limit, and you divide by 2. Have you heard that? Lower limit is given by the lower boundary is given by the lower limit plus the previous upper limit, and you divide by 2. So 50 plus 49 and you divide by 2, get 49.5. 49.5 plus 100 out of 2 minus cumulative frequency before the median class. Cumulative frequency before. So This is the median class, and we are now talking about the CF before, which is a 34. The CF in the class before this one, 34. Out of frequency of the median class, the median class is having a frequency of 22. Frequency of 22. Multiplied by the class interval, the class size, the class length. So from 50 to 54, we follow the boundaries. 54.5 is the upper and 49.5 is the lower, giving us a boundary of 5. So giving us a length. So class length is 5. So 5 is not a power. There are people that think this class length is a power at this point. No, we are multiplying by the class length at that point. 49.5 plus. Now you apply your calculator. Listen to what I'm doing. 100 over 2 is 50 minus 34. That has given us 16. So you need to multiply 16 by 5 out of 22. Giving us 3.636. 636. We can end at 4 like that. They are recurring decimals anyway. So now you can add up these 49.5 and I'm getting 53.1364. This is now the median value. And that's how you're supposed to approach the question on median. Can we now check the question on mean? Can we check the question on mean? Here is mean. Now mean is usually given by summation of fx divided by summation of f. In this case, x is the class midpoints. The class midpoints. So we can now check into that. We get back to our table and we establish class midpoints first. Class midpoints. Then from the midpoints, we can now check the product of each midpoint and the frequency. So midpoint first, then product of frequency and midpoints. I will tell you the essence of working out that. Look at it this way. You know, midpoint is given by the limits, the average of the limit, 30 plus 34, and you divide by 2. You get 32. 30 plus, you get 32. 32, make this one a 2. 32. Then what is the frequency there? 4. So we multiply by 4. We get 128. Now, these are the total marks obtained by the students within that class. We assume they are 4 and their marks are ranging here. So we assume the 4 of them are having the value equivalent to the midpoint. So we just choose a value to represent the marks inside the first class. So 30 to 34, we pick the mid value, which is our midpoint. Then we assume now the 4 of them having 32 each. We multiply. Then the next one is 35 and 39. We take the average again, we get 37. Then we multiply 37 by 10. Wait, 37 by the frequency, which is 6. Yeah, multiplying by frequency, you're supposed to be very careful there. That is the danger, actually, of working out CF before. People may forget and start multiplying by CF. No, it is F times frequency. Frequency times X. So X is here and frequency is here, not CF. Actually, we are done with CF. We can even erase it. But now that in your working, it's required because it bears a mark when working out the median. You don't have to risk. So 40 to 44, the midpoint is 42. Now 42 should be multiplied by 10. This gives us 420. 45 to 49, the midpoint is 47. Now 47 by the frequency of 14. 47 by 14. This is giving us 658. 658 like that. 50 to 54, midpoint 52. Now 52 by a frequency of 22. This gives us exactly 1144. 1144. 55 to 59, midpoint 57. Now 57 should be multiplied by 24. We get 1368. 60 to 64, we get 62. 62 should be multiplied by 14. We get 868. And finally, we're having 65 to 70. This is going to give us 67 as the midpoint by 6. We get 402. 402. So we have gotten the total marks in the respective classes. So can we get now the total marks? Summation of fx now. It's going to be, we add up everything. 128, we add 222, we add 420. You can confirm from that side. 658, we add 1144, we add 1368, we add once again 868, we add 402. I'm getting 5210. Please confirm 5210. 128 222 420 658 1144 1368 868 402 5210 confirmed. So now our mean can be obtained. Total marks, total frequency, then our mean shall exactly be 52.10. 52.10 like that. 52.10. 52.10. That is the mean mark. A very good question, ladies and gentlemen. Very, very good question. If we are together, type yes, I'm learning. That is on statistics. That is on statistics. You are borrowing a lot from shifting grades. You can look at the arrangement of work. Your work is supposed to be decent, well organized. You see, proper arrangement of your work is already a plus. There's a comedian that says, good handwriting has some marks, even when you are wrong. That's comedy, but there is a point inside that comedy that when you organize your work very well, even the stranger that is going to hold your work, they are going to be appealed. Your work should be appealing, you see? But when you are not impressive, you discourage the markers, you see? Yeah, so your work should be properly organized. Can we look at a question from transformations now? And look at a question from transformations. I'm sure it's going to help us. This one shall be great. Now, number 22. Number 22, we're being told that the vertices of a triangle ABC are 6, 1, 6, 3, 8, 1. Then the vertices of A prime, B prime, C prime is the image of ABC under rotation. Under rotation, okay? They have specified it's a rotation that gives us 4, 5 to 5, 4, 7. All right? Part A. On the grid provided, and we can see the grid, plot the triangles ABC and ABC prime. So we can plot the two triangles. So 6, 1, the first coordinate, 6, 1. So 6 on the X, 1 on the Y. 6, 1. That is our A. All right. 6, 3. 6, 3. That's our B. 8, 1. 8, 1. This is our C. So we can join and come up with the first triangle. It's good for you to take advantage of this graphical work. It is very good of you to take advantage of the graphical work, just as you can see. It's a very serious work. Very serious. So we are having the first triangle. What about the image triangle? 4, 5. 4, 5. This is what gives us A prime. B prime is 2, 5. So 2, 5. This is our B prime. Then C prime. C prime is 4, 7. 4, 7. C prime, like that. We can join to come up with our triangle. A to C and to B. That. So we have the two triangles. Instructions. According to instructions. According to the instructions, we are already having the two triangles properly plotted. Then now we can check part B of the same question. In part B, the examiner is telling us to find the center and angle of rotation by construction. So to find the center and angle of rotation, okay, the center is usually determined first. And how do we determine the center? We join a point and its image. Then we bisect the line connecting that. If it's A, we join it to A prime. If it's B, we join it to B prime and we bisect. So we can start with the B. We join B to B prime. I can use a different color now. Let me change to, black, like that. So we join a B to B prime. Let me start by that. A B to B prime. Then now after that, we bisect the line joining B to B prime. We bisect that line. So this line is supposed to be bisected perpendicularly. Perpendicular bisection of this line. So the perpendicular bisection will give us this line. The perpendicular bisection will give us such a line. Okay, so we have connected B to B prime and bisected the line connecting. Then we can also move to another coordinate like A and A prime or C and C prime. Usually 2 are enough. So we can proceed to A prime. That's A prime are here. A and A prime, we connect them using a straight line. A prime. Okay. A prime like that. Then the line connecting A prime, the line connecting A prime can also be bisected. When you bisect it perpendicularly, see, when you bisect it perpendicularly, this is where you shall pass. So now you can notice something, that the two green bisectors are meeting at a point. That particular point becomes our center of the rotation. So to find the center of a rotation, you need to connect a point and its image, B and B prime, then you bisect perpendicularly. Is that okay? Then you move to A prime. Then you again bisect perpendicularly. Then now you identify where the two are meeting. So the center is 2, 1, coordinate 2, 1. The center is coordinate 2, 1. That is the center of the particular rotation. What about the ankle? Remember, the ankle should be accompanied by the sign, in other words, by the direction. Therefore, we can use any coordinates now, like B and B prime, or C and C prime, or A and A prime to check the ankle. So let me use a color that I've not used so far, and that is can use this particular, I can call it yellow. It might not be yellow, but let me call it so. So can we use B and B prime, whereby I connect B to the center. I connect B to the center. B has been connected to the center. Then from the center to B prime. From the center to B prime. Then after that, now we confirm the angle between, the two lines, connecting a point to the center, then moving to the image. You can see it's an equal distance to the image. So can we identify the angle? I'm using my protractor to confirm the value of this angle. And this angle is exactly 60. The angle is 60. Now we check also the direction. So we are getting an angle of 60 in anti-clockwise. So we have moved in the anti-clockwise direction. Anti-clockwise means a positive angle. So through positive 60 degrees. So it's a rotation, center 2, 1, 60 degrees positive, or you can say 60 degrees anti-clockwise to show the direction anti-clockwise. I've considered B and B prime. It's good for you to know, just before I proceed to another part of the question, you would still have considered C and C prime, or A and A prime. For example, when we connect A to the center, then now to A prime, like that, we can still establish the angle from A to the center, then to the image. And I'm realizing that the angle is confirmed to be exactly 60. The angle is confirmed to be exactly 60. You can do the same. You can do the same with the C. So you just need one point and its image. You connect all of them to the center. Then you identify the angle. The direction is confirmed to be the same. So now we have confirmed the angle of rotation together with its direction, or simply positive 60. In case it was clockwise, we would have said negative 60. This is center to 1. A very good question in part 1. Now, after that, can we check part B together? Now, in part B, we're being told to determine the vertices of a triangle A double prime, B double prime, and C double prime, where it is the image of A prime, B prime, and a reflection in the line y equals to negative x. So the first thing that we're supposed to establish is the mirror line where this reflection is occurring. So this particular reflection is along y equals to negative x, meaning that the mirror line is, when y and x are here, when we are told y equals to negative x, it means if this is a 1, then y is a negative 1. If this is 2, negative 2. If this is 3, negative 3. So the values of y are the negative values of x, meaning that the mirror line now shall be flowing in this way. The mirror line is 1, -1, 2, -2, 3, -3, like that. That's where the mirror line shall be 4, -4. If it's -1, we have +1, like that. The line that passes through the center in such a way. So we can first plot the mirror line because you can't reflect before you have a mirror line. You cannot reflect without a mirror line. So our mirror line will take this color. Let's come up with it. Let's come up with it. We have our mirror line there. It's good you name it. It's good you name it line y equals to -x. Y equals to -x. Now, we are supposed to reflect. We are supposed to reflect. We are supposed to reflect the first image to get the second one. So we are reflecting if it's B, and to reflect means you join a point. Look at this. You join a point to the mirror line perpendicularly. Seeing a perpendicular line. You join if it's point B, we join it to the mirror line perpendicularly. Then we move an equal distance on the opposite side. So an equal distance opposite side. Meaning that now from the mirror line to point B, now you move on the opposite side an equal distance, you'll find yourself at a point here. When you move an equal distance, you shall be at a point here. So this becomes our B prime. We do the same for C, whereby you can see you are just supposed to proceed with the same line. 2 more units. Like that. Then from the mirror line to point C, now we are moving on the opposite side an equal distance so that we get our C. So C double prime, it's actually double prime even for B. It's a double prime like that. Then for point A, we do the same. So we are joining A perpendicularly, to the mirror line. Then we proceed an equal distance on this other side. An equal distance from the mirror line to where A is. Now on the opposite side, it will bring us to a point here. This is going to be our A double prime like that. So with this now, we can join. Let me use a red. We can join now A to B. Then to C. And to B. We enclose like that. So we are having now our triangle reflected. Our triangle are properly reflected. Let me confirm these units. F 1, 2, 3, 4. F 1, 2, 3, 4. Yes, it's an equal distance on the other side. You see that? Properly worked out. That is now a reflection. You connect to the mirror line perpendicularly and you move an equal distance to the other side. So now we can state the coordinates. A double prime. It's here. -5, -4. B double prime. B double prime should be -5, -2. C double prime. C double prime is here, -7, -4. Very good work. Very, very good work. Can we check part D of this question? Checking part D. Now we told to draw, this is the third image now, A triple prime, the image of the second one, and a reflection. It's again a reflection, okay? It's another reflection in the line x equals to 0. X equals to 0. Okay, when we say x equals to 0, it's another name of the y-axis, because we are supposed to establish a vertical line at x equals to 0. So x equals to 0 is at the y, because x equals to 1 will be a vertical line at 1, x equals to 2 at 2, x equals to 3, vertical line at 3. But when we say x equals to 0, then it means the vertical axis. So we are reflecting along the vertical axis, meaning that ours now is to join coordinates. Look at this. Ours is to join coordinates from a point. I've already used such a color. Let me advance to this one. So we join if it's point B, we join it to the mirror line, and we move an equal distance to the opposite side. So it was 5 units away. It is also supposed to be 5 units on this side. So this gives us our B triple prime. We do the same for A and C. So we join A to the mirror line, which is 5 units away. So we move 5 units again on the other side of the mirror line. And for C, we shall move 7 units away, meaning that A shall be here, triple prime, and C triple prime shall be there. So now we are having the coordinates of the image. Now we can connect. We can connect, ladies and gentlemen, to come up with. We can connect A to B, to C, then to B, to point B, like that, to point B. So this particular triangle has been reflected to this side along the vertical axis, which is line Y, which is line X equals to 0, the Y-axis. We have drawn, we're just told to draw, not to state coordinates, but you can move ahead to draw. You can move ahead to draw. Now, after such a transformation, else that we are doing is to answer part E of the question. In part E, we told from the triangles drawn on the grid, state one pair of triangles that is directly congruent, and Roman 2, oppositely congruent. In congruence, there is something that I want you to understand. When figures are equal in size, we say they are congruent. But now for direct congruence, it depends on the transformation that has been applied. So for direct congruence, the transformation that should be involved is a rotation and translation. You find that you can pick one of the triangles and directly place it on the other, or you place it on the other after turning through a uniform angle when you use rotation and when you use translation. So there's direct congruence. So we identify where any of this has been used. And for your information, we didn't have any translation. So we are only supposed to pick direct congruence where rotation has been involved. So where was rotation involved? Where was rotation involved? from the first triangle to the second one. So A, B, C, and A, B, C prime. That is the only pair which is directly congruent. It means when you lift this triangle, you see when you take it directly to this one, they may not align. But if you twist clockwise through 60, you place it here and you twist through 60, the time C will be fitting to C prime, B will also align with B prime, and A with A prime. So that is direct congruence for a rotation. It is only a translation which will fit exactly. Now, opposite congruence, it is a reflection only. So reflection should be involved. So for opposite congruence, you find that you cannot place one triangle into the other. And for that case, we can pick now examples like this first image and the second one. There was a reflection. So they are oppositely or inversely congruent. There is also another pair, but we just needed one pair. Also the second image and the third one, it was a reflection that was involved. Therefore, that was opposite congruence. You see that? So you should be very keen to identify congruence and what type of congruence. And you're also supposed to know the transformation involved to produce what type of congruence. I hope that's a good question. When we mean opposite congruence, we mean when you lift this triangle and you place it into the other, you know, by the time B will be fitting on the other B, C will still be on this side. And if you tilt to have C fitting where C is, then B will have moved to another direction. Therefore, they can't fit onto one another. That is opposite congruence. They are congruent, yes, equal in everything, but oppositely congruent. A very good question. Very, very good. If you're getting something on transformations, type yes, I'm learning. Yes, I'm learning. Personally, I like the question. I like number 22. And together we can proceed to number 23. Should you be reminded of our programs? We are hosting powerful speakers. The likes of Dr. David Mwangangi, Migwani Boys High, who is going to lead us through a very strong topic, finishing strong. So please do not be left out. You can use our number, which is on this poster, or I can write it 0704 153366. Everybody so far should have crammed my number actually. Every follower of Shifting Grades should be having this number, should be having our contact in their head, in their fingertips. 0415 3366. Finishing strong. Finishing strong. The charges are only 500 Kenya shillings. You can pay, commit your 500 and transform your life. Remember, we are also hosting Sir Alex Kipruto for a very serious topic again, managing peer pressure. This is one of the most experienced mentors and counselors based at Alliance High School, and you can be sure he can help us navigate this topic successfully. So kindly commit yourself and be present on the Friday of 14th August 2026, and all shall be well. A very good program. This one, I like it. A very, very good program. So do not be left out. Then be also reminded that we are having one-on-one classes with continuing students and with also KJSEA and KCSE candidates. We are hosting very powerful speakers. Bear me witness that anybody taking part in this, they are regretting joining late. They are very happy, impressed, transformed. So please join the other learners, join the other students, and maximize on your potential, maximize on your performance. I know you are very sharp, but when you enroll to this, you will polish up your skills. You shall be greater than how you will have joined us. You will live with a testimony, and we are wishing you all the best. Checking number 23. Now, a rectangular swimming pool measuring 80 meters by 20 meters contains water to a depth of to a depth of 500. Look at that. 500 centimeters. Okay. Now, on the deep end, and 150 centimeters on the shallow end, as shown on the diagram. So 500 on the deep end and 150 on the shallow end. That is well understood. Calculate the volume of water in the pool in liters. One thing that you should be able to understand so far is that this pool is having a uniform cross-section. So what is the uniform cross-section? It's here. The uniform cross-section is trapezium in nature. Then now a length. So for every solid, you are supposed to identify the uniform cross-section. It's trapezium. You know, you can't say this rectangular is uniform because as you move along the length of 20, the rectangle of 150 by 8 is not uniform throughout. It changes. But now the cross-section area of a trapezium is found here, and along the length, it can also be seen. Sorry, it can also be seen using the incomplete lines here. You can see. So the cross-section moves along throughout the diagram. So volume needs cross-section area times length. Volume equals to cross-section area and its trapezoidal. That is cross-section area, then times the length. Cross-section area is trapezium. So formula of a trapezium. Substituting these will be half. Then we're going to use the same unit. Two parallel lines of the trapezium shape. 500 and 150. So this is 5 meters and this is 1.5 meters. So we're using 5 and 1.5. Then the height between them, perpendicular height between the two parallel lines. This is a parallel line to this one. Then now we talk about the distance between them, the perpendicular height between them, which is can be translated from 20. Is also 20 meters. So we apply 20 meters there now. That is the area of the cross-section. Then now times the length. So cross-section and a length, a uniform length of 8. That interpretation requires our students to be very keen. So half multiplied by 6.5, that's after adding, multiplied by 20, multiplied by 8. Can we compute this, ladies and gentlemen? We can compute 0.5 times 6.5 times 20 times 8. I'm getting exactly 520 cubic meters. Then now we convert to liters. You know, we're supposed to know that 1 meter power 3 is equivalent to 1,000 liters capacity. This is volume to capacity. So when the cubic meters are 520, then you can be sure that this capacity shall be, we multiply because each meter cubed is having 1,000. We multiply by 1,000. 520,000 liters. That's now after conversion. A good question. A very, very good question in part A of number 23. Now, can we check part B of the same? Can we check part B of the same? In part B, the examiner is talking about the density of water in the pole being 1.2 grams per cubic centimeter, determine the mass in kilograms of water in the pole. Now, one thing that you're supposed to know is that mass, you see, generally, you say that density is mass over volume, meaning that mass is the density times volume. Again, if this is the mass now, we are supposed to work with density in SI units. So density should be multiplied by 1,000 to become kilograms per meter cubed, because we can't work with the grams per cubic centimeter, yet the volume is in meters cubed. So the density equals to 1200. We multiply it by 1,000 kilograms per meter power 3, like that. So after that now relation, we can start now working out the mass, which will be density times volume. Density times volume. So now I'm having 520 multiplied by 1200, giving us exactly 624, sorry. 1,000 kilograms. 624,000 kilograms. See that? Very good question. Very good question. Now we've gotten the mass. We can check part B. You can check part C of the same question. Part C of the same question. Now in part C, we're being told that when 10 identical cubes are immersed fully in the pool, I hope you are reading that carefully with me, the volume of water that overflows is 5.12 cubic meters. Calculate part A, the volume of one such cube. It's good for you to know this. It is very good for you to know this, that this is called a displacement method. From practicals in Form 1 physics, everybody did physics in Form 1, even if you didn't choose it when you advanced. When you started thinking that biology is the opposite of physics, which is a myth, you can also take 3 sciences. So you did a practical or a demonstration on what you call displacement method to determine volume, more so when irregular shapes were involved when you are in Form 1. And you said when you're having a container, like the Eureka can, for example, like the Eureka can, that is the concept I want to instill in your head. Then water is at this point. This is the sprout. Then now you have a beaker here to collect some water. Then you immerse a solid here. The solid displaces water. Now, when you collect the water here, then we usually argue that the water collected here is having volume that is equal to the volume of the irregular shape that you've immersed. Therefore, we can say that volume of the 10, when 10, you know that word 10, you're supposed to be very keen. The word 10, there are people who just see cubes. They think it's 1. Therefore, volume of 10 cubes, because they are displacing this amount of water, then they bear the same volume. So volume of each cube shall be 5.12 divided by 10. So each will be having 0.512 cubic meters. 0.512 cubic meters. That is the volume of each, because the 10 of them have displaced. The 10 of them have displaced, and they are equal. They are identical. All right. So we can look at Roman 2 of the same part of the question. Find or calculate the surface area of one such cube. So the cube is already having a volume, meaning that one side, you see volume is given by side power 3, meaning that to get side, we need the third root of the volume. Therefore, one side is going to be the third root of 0.512. Can we get the third root? Shift power 3, 0.512. This is giving me 0.8 exactly meters. So the length of one side of the particular cube or of each cube is 0.8, meaning that, look at the surface area that we need, square centimeters. So in centimeters, can multiply by 100, giving us 80 centimeters. So one face, one surface is equal to 80 by 80. Since it is cubic, it's going to be the same 80 by 80, giving us 6400 square centimeters. That is one surface, area of one surface. So we can now talk about total surface area. Being a cube, it has 6 such faces, 6 of them. So by 6, so that you may get the total surface area, 38,400. 38,400 square centimeters. This is now the total surface area of one of the cubes. One such cubes in square centimeters according to the instructions. Is that not a good question? Is it not an interesting question? Are we together? Are we learning together? Are you understanding something? Well organized work. A very good question. It's very easy to scoop your 10 marks when you understand what the examiner wants. Very easy for you to maneuver and get your 10 clean marks in every question. This was very simple, but it required one to understand very well. So now we can advance to number 24. All right. Yeah, number 24. Given the graph y equals to x squared minus 9, x plus 3, find part A, the x-intercept of the curve. X-intercept of the curve. There is something that you're supposed to know, that at the x-intercept, whether for a line or for a curve, the values of y are usually 0. Therefore, we rewrite our equation x squared minus 9 into x plus 3. This is equal to 0. So if this times this equals to 0, it means either of them can be 0. So x squared minus 9 can be equal to 0, or x plus 3 can be equal to 0. Now from this one, we can factorize. Let's say x minus 3, it's a difference of 2 squares, or x plus 3 equal to 0. And on the other side, we're also saying x plus 3 equals to 0. So it has already been factored here. It has already been factored there. So even when we include now this, it will be a repetition of what we are already having. The x-intercepts are 2. And being a cubic function, you can be sure that it cuts the x-axis at 2 points. Therefore, no wonder the 2 values of x. So from this, x minus 3 can be 0, or x plus 3 can be 0. So we don't have now to work out this part. We can now deal with this only. meaning that x can be 3 or x-intercept can be negative 3 because this will become negative on the other side. So we have two possible x-intercepts. Two possible x-intercepts. Two possible x-intercepts like that in this particular equation. Two possible x-intercepts. Can we now proceed to part B of the same question? In part B, we're being told to find the y-intercept of the curve. At the y-intercept, the values of x are 0. Therefore, we come to the same function, and where there is x, we substitute with a 0. So y equals to 0 squared minus 9 into 0 plus 3. So now we are having negative 9 and positive 3, giving us a negative 27. So our y-intercept is negative. Our y-intercept now is negative 27, like that. We can now check part C of the question. In part C, we're talking of finding the stationary points. Stationary points are also called the turning points of a curve. Turning points of a curve. Turning points of a curve. So there is something that you're supposed to know, that at the stationary points, gradient is usually 0. So we can first expand so that you may get the parent equation here of y. The parent equation of y. So y equals to, from this, we can start by x times everything in the second bracket. So x squared into x plus 3. X into x plus 3. Then negative 9 into everything again. Negative 9 into x plus 3. Then we expand. Equals to x power 3. 3x squared. Negative 9x negative 27. Do we have any terms to group? Not really. No terms to group. So we are already at the answer. Now we have expanded. After expanding now, I've said at the stationary points, gradient equals to 0, meaning that because we have the function, we can find the gradient function, which is found by differentiating y with respect to x. We differentiate y with respect to x. To differentiate means the power should multiply the term such that we have a 3x, and the power again reduces by 1. Then the same is repeated in the next. Remember, this is a polynomial, so you differentiate each term. This is a x power 2, so the power multiplies here. It becomes 6, and the power of x now reduces by 1. This is x power 1, so when 1 multiplies, negative 9 remains unchanged. Is that okay? Then x is now becoming power 0. Anything power 0 is 1. So we have negative 9 times 1 because it's now x power 0. Then here, it's a negative 27. So because we can't see x, it means there was x which was to power 0, meaning that when the power of 0 multiplies everything, the whole constant disappears. So that's how constants disappear during differentiation, during differentiation. Therefore, the negative 27 now disappears. We have our gradient function. Now we are saying that at the turning points, the value of gradient equals to 0. So we can find values of x when gradient is 0. So we equate now the gradient function. We equate the gradient function to a 0. When the gradient function has been equated to a 0, we can now solve and get the possible values of x. We need one thing that you're supposed to know here. I'm realizing that 3 is common. It can divide through, instead of working out these large values. When you divide everything by 3 in this equation, to be x, to be 2x, to be -3, it will remain as 0. So you can make an equation in its simplest way possible. So here we're talking of products of a by c. So the coefficient of x squared is our a, 1, and the constant c, get a product of -3, then a sum of +2. Two values that when we multiply them, we shall get -3, but when we add them, it will be a positive 2. Is it 3 and a -1? Huh? Is it 3 and a -1? Confirm that. Product, -3. Sum, +2. And those are the two factors. Those ones are the two factors. Now, with the two factors like that, you may now allow me to proceed with now the solution of my equation. And I hope you are following and also solving from that end. So we can now agree that 2 can be substituted with 3 and -1. So we rewrite our equation as x plus 3x and minus x. Instead of, you can't say 1x, just x. Minus 3 equals to 0. Factor out from the first 2, factor out x and remain with x plus 3. In the other 2, we factor out a -1, so that we remain with x plus 3. This is equal to 0. So from the brackets, you can say x plus 3, and outside the brackets, x minus 1 equals to 0. So the product equals to 0, meaning any can be 0 or both. So x plus 3 equals to 0, or x minus 1 equals to 0. You see, this is now going to give us, exactly x equals to -3 or x equals to 1. Those are the two values at the stationary points. Two values of x at the stationary points. Now, what are we calculating? The stationary points. A point is given as a coordinate. Now that we have the values of x at the turning points, we can find the values of y so that the stationary points can be written as coordinates. So when x is -3, y equals 2. Look at that. Y shall be equal to -3 power 3 plus 3 into -3 squared minus 9 into -3 minus 27. This will give us what? We can now check that. So I'm feeding the function. I'm feeding the whole function in my calculator. Opening brackets, -3 cubed plus 3 into -3 squared minus 9 into -3 minus 27. So I'm getting exactly 0. You can also confirm getting a 0. So if when x is -3, y is 0, then it means we have a coordinate -3, 0 as a turning point. What about another coordinate? When y is 1, when x is 1, what will be the value of y? We substitute again in the function, and we will have 1 power 3 plus 3, 1 squared minus 9 into 1 minus 27. This is 1 plus 3 minus 9 minus 27. 1 plus 3 minus 9 minus 27. So I'm getting negative 32. I hope that is properly computed. Therefore, the other stationary point is 1, negative 32. 1, negative 32. See, we are already having the two stationary points, the two turning points, negative 30 and 1, negative 32. Those are the two turning points, At that point now, we can proceed to part D of the question. Part D of the question. In part D, we're being told to state the nature of the stationary points in C above. State the nature of the stationary points in C above. All right. So we're supposed to establish the nature. I want to show you a simple way of demonstrating the nature of the turning points. You come up with we want to see how the curve gradient is behaving. So let me draw some points here. We can have some values of x. For the first curve and also for the second one. Then now the gradients and how it behaves. How the gradient behaves, so that you may know the nature of the turning points. The nature of the turning points. We'll also be stating the nature. Okay. So we are having values of x, then we are having the gradient dy dx. The gradient is given by what? 3x squared plus 6x minus 9. 3x squared plus 6x minus 9. So, sorry, just allow me work on my thing. We want the value of the gradient, dy dx, which is given by 3x squared plus 6x minus 9. 6x minus 9. You see that? So this is now the value of gradient at the particular points of x. So for the first turning point, you can choose a value before the turning point, at the turning point, and after the turning point. The first turning point is a negative 3. X equals to negative 3. So this is now the thing I want you to observe keenly. At negative 3, we place it at the middle there. The value of gradient is 0. So we want a point before negative 3 on the x-axis, like negative 4, and after negative 3, like negative 2. So we check the value of gradient at negative 4. What is the value of the gradient at negative 4? So the value of gradient, we have the gradient function, so we can find it. We are very sure that at negative 3, the value of gradient is 0. What about at negative 4, just before the turning point? 3 into negative 4 squared. Then we add 6 into negative 4. Then we subtract 9. This is giving us exactly 15. What about at negative 2? We check gradient at negative 2. It will be 3 into negative 2 squared plus 6 into negative 2 minus 9. This is now going to be negative 9. So you can see that the nature now can be stated at this point. The nature can be now demonstrated. Just to demonstrate, the gradient is changing from positive. You know, if positive gradient behaves this way, then it becomes a 0. We use a flat line. Then now it becomes a negative gradient like this. So a turning point, which is like this, from positive through 0 to negative gradient, is called a maximum point. So it means the first turning point, which is negative 3, 0, is a maximum point. Maximum point. Where gradient changes from positive through 0 to negative, that's a maximum point. So now allow me partition here so that I may go to the next turning point. The next turning point. So we are talking about now at the next turning point where x is what? Where x is positive 1, the next turning point where x is 1, we know that the gradient is 0. What about at a point just before the turning point, like 0, and after the turning point, like 2? What will be the values of gradient? So we can substitute 0 and see the value of gradient that you get. When you substitute 0 in this function, for you to get the value of gradient, this becomes 0, 0, and we remain with a negative 9. What about when we substitute positive 2? What value of gradient are we going to get? So we shall have 3 into 2 squared, plus 6 into 2 minus 9. I'm getting exactly 15. You can see things are interchanging here. Exactly 15. Now with 15, this is an indication that at this particular point, gradient is changing from being negative through 0 to a positive value. So the curve is curving this way at this point, turning that way, meaning that the point 1, negative 32 is a minimum point. It's a minimum point. It's a minimum point. Minimum point. So minimum point is a nature where the gradient is negative, then 0, and to positive. Negative, 0 to positive. Where it is positive, 0 to negative, it's a maximum point. So that's how we establish. So you should be knowing the general shape of a line when gradient is negative, the general shape of a line when gradient is positive, so that you are able to establish the nature of turning points. A very good one. You're getting something. If you're learning something, type yes, I'm learning. Type yes, I'm learning. Then now we can go to part E of the same question, which is now curve sketching. Sketch the curve. Sketch the curve. Sketch the curve. All right. When you are sketching the curve, this now becomes very easy because you have already worked out almost everything that is important for a curve sketching. The intercepts and the turning points. You actually need the intercepts and the turning points, and we already have everything. So we now, and remember, it's a sketch. Please remember that we are sketching. When you have that one in your mind, you will not struggle. There are some people who will ask themselves now, and where is the graph? A lot of stories. Yet we are curve sketching. So we are not curve drawing, we are curve sketching. So a sketch of the curve vertical axis, another sketch of the horizontal axis, another sketch of the horizontal axis. Can have a 0 there. We can look at the sensitive points now. Can we start with intercepts? X-intercepts are 2 at 3 and negative 3. At 3 and negative 3, negative 3, and also 3. What else? Y-intercepts. The y-intercept is negative 27. It's here. Negative 27, the y-intercept. Negative 27. Negative 27, like that. It's just a sketch, not an actual thing. Then what about the turning points now? Those are the intercepts. What about turning points? The first turning point is negative 3, 0, which is at this point, and it's a maximum point. Maximum point. The other one is 1, negative 32. So 1 can be here, negative 32, somewhere below. Negative 32 can be there. So we are having our two turning points. This point, which is also an x-intercept, it's also an x-intercept and also a turning point. X-intercept and also a turning point. At a turning point, the curve will just turn there, but not going beyond there. Meaning that if we start now installing our sketch curve, this being a maximum point, this is how the curve shall turn at such a point. That way. Then now we proceed with in mind that it has to cut the x-axis at a point here. I'm going to, of course, we are sketching, so I'm going now to change. So we can turn and ensure that the x-axis is cut again. The x-axis is cut at such a point. So the other turning point now can be sketched at this point. This is now coordinate 1, negative 32. 1, negative 32. You don't even have to show it. It is already in your information up there. That's just a sketch of negative 132. That means you have to go beyond negative 27 so that you may turn. Being a minimum point, that is the nature of a turn that we expect. Negative 30 being a maximum point, this is the kind of a turn that we expect. Then you are cutting the x-axis at negative 3 and positive 3, and the y-axis at negative 27. So this is the curve properly sketched. So here is the curve now. Sketch the curve. So we can now name our curve that has properly been sketched. This is curve y equals to, we can use the original equation, which was x squared minus 9x plus 3. Is that so? Yes. That was the original equation of the curve. So that is it. You curve sketch. You can check more videos on the platform where we have done curve sketching and you continue polishing your skills. Otherwise, thank you for following up. That is the section 2 of Mokasa joint examination, Mokasa 2 2026. A very good section. Thank you so much. We continue inviting you to our interactive classes, and even in the month of November, December, for the continuing students that are not going to be doing the national examinations, we shall occupy them over the holiday. So please turn up. Please turn up and join our classes. So thank you so much. You can also join our motivational sections, guidance and counseling sections. Under Shifting Grades Online School, we're going to host very powerful speakers, very, very powerful speakers. Like on the 14th of August, we are hosting Sir Alex Kipruto from the Alliance High School, who is the CEO and also the founder, Ambassador Foundation. He's a great speaker, a mentor, and he can be trusted in his work. So the topic shall be managing peer pressure. Then later, in the same holiday, we shall be hosting another powerful speaker, Dr. David Mwangangi, who is a teacher at Migwani Boys High School, a licensed professional counselor. It's a person I know, and you can trust in his powerful work. The topic shall be finishing strong. So please join us. You can see the charges are very manageable. You can commit your 500 and you transform the life of your child. Commit your 500 and change your destiny. Otherwise, thank you so much. See you in our meetings. Bye bye for now. Thank you.